Hi, this is a lesson about the International System of Units, or as you probably know it, the metric system. The countries that you see listed on the screen, these are the only countries in the world that do not use the metric system as their official system for measurement. You know, in the United States, we have embraced the metric system a little bit. Like maybe we measure the track in meters, whereas when I grew up, we used to measure it in yards. But for the most part, our units in our everyday life remain to be those imperial units based on the British system, even though around like 1965, 1970, Britain switched to the metric system. We stuck with the units that we kind of inherited from their colonial rule. Now, our goal in this lesson is for you to be able to identify the base and derived units in the metric system, know the prefixes and values and symbols that we are going to use in chemistry this year, and be able to convert using dimensional analysis and the factor label system with those metric prefixes and values. In the International System of Unit, you have some base units where there's an actual physical object, for example, like length in France, where they have this International System of Units sort of headquartered. For example, they have like a platinum iridium rod that is exactly 1 meter long, and that kind of standardized what is a meter for everybody around the world. Now, derived units are units that are like made by combining some other ones, like speed, meters per second. And even volume is actually a derived unit. Let me show you how that works. The volume that we know as the base unit, the liter, and then 1/1000th of that, the milliliter, those are actually derived from distance or length measurements. If you have a cube, and I'll try to draw a cube, I'm not the best artist, but if you have a cube and each side is 1 centimeter, you know that you find the volume of a cube, length times width times height. So this is 1 centimeter cubed, 1 centimeter times 1 centimeter times 1 centimeter. This is defined as the volume equal to a milliliter. Okay. And I would, if I'm you, make sure that I memorize this, that a centimeter cubed and a milliliter are the same thing, because this is going to come up over and over again throughout the year. And knowing this and that these are equal makes a very clean and easy conversion among units when we're dealing with volumes. So something that you would like to know. A cubic decimeter, so a decimeter is 10 centimeters. So if I had a cube and it was 10 centimeters on each side, okay, its volume, 10 times 10 times 10, that's 1,000 centimeters cubed, which that's 1,000 milliliters, and that's a liter. So a cube that is 10 centimeters in each direction is equal to a liter. Well, 10 centimeters is a decimeter. We're going to get our prefixes in a minute. So that means that this volume is 1 decimeter cubed, 1 decimeter times 1 decimeter times 1 decimeter, and that is equal to, gosh, I'm not very good sometimes. I don't know why that happens sometimes, but that is equal to 1 liter. So, looking again at, okay, what's something that we should memorize? This equality right here, kind of nice for you to know that a decimeter cubed and a liter are interchangeable, that they are the same thing. And knowing those two things, that a centimeter cubed is a milliliter and a decimeter cubed is a liter, Knowing those two things is sure to make your conversion life a lot easier this year in chemistry and beyond in science. Now, there are many more metric prefixes than this, but these are actually the ones that I want you to know. Here you have your base unit, okay? And there are other base units, but the three that you really need to know, the liter, the meter, and the gram for volume, distance, and mass. And deci, centi, milli, and nano, these are fractions of the base unit. Here's the symbol to represent it. And then this number is how it's related to the base unit. For example, 1 decimeter is equal to 1 times 10 to the negative 1 meters. A decimeter is 1/10 of a meter. Knowing this gives you equalities that you can then use to do conversions with dimensional analysis throughout the year. And we're going to practice those today. You've got centa, and it could be a centigram is 1 times 10 to the negative 2 grams. It could be a centiliter is 1 times 10 to the negative 2 liters. You've got milli. If it's a millimeter, mm, then it's 1 times 10 to the negative third of a meter. If it's a milligram, then it's 1 times 10 to the negative third of a gram. Nano, notice there's 6 powers of 10 here. There are other prefixes in there. For example, micro is 10 to the negative 6. You might use that in AP Chem or in physics, but we don't really need it in here. So I'm only asking you to know the ones that we're going to use. And the reason we use nano is that light waves in unit 3 are going to be measured in nanometers. Then you have metric prefixes that are multiples of the base unit, and you can see their symbol and how they are related. So for example, if I have a hectometer is 1 times 10 to the 2, like here's a hectometer, that's 1 times 10 to the 2 meters, or 100 meters. Mega is 10 to the 6. Notice we skipped a few in there, 3 powers of 10. Again, they exist. We don't need them. Why do we need mega this year? We need mega because we, again, will use that to measure frequency when we study light in unit 3. I always tell students I think mega is easy to remember because it's equal to 1,000,000 of the base unit. And you guys are all used to that lottery game, Mega Millions, right? So how might you use them to then complete conversions? So for example, here, if I have 5 liters and I want to convert that to milliliters, I know from the previous slide that milli means 1 times 10 to the negative 3 of the base unit. That's supposed to be a 3. So I would take 5, divide by 1 times 10 to the negative 3, and I get 5,000, or if you have it in, scientific notation, 5 times 10 to the third milliliters. Sorry. Oh, I didn't have enough room to fit that in there. My label. Hold on. So that would be 1 times 10 to the 3, or 5 times 10 to the 3, milliliters. So your answer is either 5,000, or if you put it in scientific notation, there you go. 5 liters, 5,000 milliliters, same volume, just expressed in different units. Try the next two. I'll give you a minute and actually just try number 2. Don't try number 3 yet. Just try number 2. So remember the dimensional analysis lessons start with the number and label that you're given and set up a factor. You want to convert from milligrams to grams. So then you have to look on the chart, or maybe you know it. So 1 milligram is 1 times 10 to the negative third grams. You multiply, you get 0.025 grams, or if you had it in scientific notation, 2.5 times 10 to the negative 2 grams. Either one is fine. Now, the reason I said hold off a little bit here on number 3 is this one, you're going to need 2 conversions. So you have a number in centimeters and you want to put it in kilometers. So first you want to go from centimeters to meters, and then we know how meters and kilometers are related. We know that each centimeter is 1 times 10 to the negative 2, or 1/100th of a meter. We know that each kilometer is 1 times 10 to the third, or 1,000 meters. So we are multiplying by 1 times 10 to the negative 2 and dividing by 1 times 10 to the negative 3. As a result, we're going to get, let me see, I think we should have 4 zeros, 375 kilometers. And you might end up with that in scientific notation, which is fine as well. Now, this is a really small number. A kilometer is a large unit of measure, so you should end up with a small, a small answer. So it makes sense. You always want to look at your answers and think, hey, does that, make sense? Remember the cubed unit. So, trying to convert those, remember from the dimensional analysis lesson, we have cubed factors. We don't need to do that here because we know that 1 centimeter cubed is equal to 1 milliliter. We're fortunately getting rid of that cube just in that very one simple conversion, so it's very handy. And then we know that a milliliter is equal to 1 times 10 to the negative third liters. These threes are hard to make with this little pen, sorry. And as a result, you get 0.708 liters. Or if you put it in scientific notation, 7.8 times 10 to the negative 2 liters. Either way, remember that this volume and this volume and this volume, they're all the same. They represent exactly the same volume. Try number 2 and try number 3. I'll give you a few minutes. In number 2, you want to convert from hectometers to meters and then meters to millimeters. So it is going to be 2 steps, which was similar to number 3 on the previous slide. And then this one with the cube, number 3, is similar to number 1. You can look back at this for a little bit of a model as to how to do that. Remember that decimeters cubed are the same as a liter, and then you can go from liters to kiloliters. In the end, the answers that you should get, this one is 82,000, or, 8.2 times 10 to the 4th. And the bottom one is 4.2. Now remember, if you're struggling at all with these, one of the biggest things is that, you need to spend some time getting to know the prefixes and their values. A lot of times people make up little sayings, I've heard different ones. I'm trying to think from math teachers, going back, like like kids hate doing my for the meter, dumb, crazy metrics. King Hector dances. I think it was much for meter, Graham, or much like girls doing crazy moves. I've heard all kinds of sayings. Very rarely do I hear a saying, and I don't recall any that include mega and nano. But I would encourage you to, maybe come up with a saying and, maybe use that to help you remember the prefixes and their values, how they relate to the base unit. And then throughout the year, you're going to get more and more practice at the conversions. You get a little practice in bookwork and WebAssign and worksheets that we do. Of course, practicing helps to ingrain that skill, make it a little muscle memory in your head. But at any point, if you're struggling with how to do this, come in during Flex and ask for help. I'm certainly happy to sit down and help you out. So good luck. Thanks.